हेलो एवरीवन, ज्ञान विज़ार्ड में आप सभी लोगों का वेलकम है। मैं हूं अजमल। इस वीडियो में गॉस लॉ को यूज़ करके एक स्फेरिकल सेल जो कि इसके सरफेस पर यूनिफॉर्मली चार्ज डिस्ट्रीब्यूटेड है और उसकी सरफेस चार्ज डेंसिटी सिग्मा है, इसकी वजह से इस सेल के आउटसाइड एक पॉइंट पी पर इलेक्ट्रिक फील्ड इंटेंसिटी कैलकुलेट करेंगे। तो पहले देखते हैं गॉस लॉ क्या है। गॉस लॉ स्टेट्स दैट टोटल फ्लक्स कमिंग आउट ऑफ ए क्लोज्ड सरफेस is equal to the total charge enclosed inside this surface divided upon epsilon naught। यहाँ पर जो स्फीयर है, जो बेसिकली हॉलो स्फीयर, इसकी रेडियस कैपिटल आर और सेंटर ओ है। P is a point outside this sphere where we have to calculate the value of electric field intensity. First of all, we will imagine the Gaussian surface. This Gaussian surface is a concentric sphere passing through the point P. We'll take a small elemental area ds enclosed around the point P. Here, the charge is uniformly distributed and it is positive, therefore, electric field will be radially outward. This Gaussian surface is concentric and it is symmetric also with this sphere. Therefore, electric field at every point will be uniform. That means its magnitude will be constant. Here, the direction of the small area and the electric field intensity both are same and radially outward. That means angle between them theta is equal to 0. Let's first find out the small flux d phi passing through this small area ds. This will be equal to the E dot ds. This is equal to the E ds into cos theta. Theta is equal to 0 degree and cos 0 is 1. Therefore, this is equal to the E ds. Now we will calculate the total flux phi, which is equal to the integration over a closed surface E dot ds. Which is equal to integration over closed surface E ds. Now E is uniform, that means it's constant, and constant is always taken out of integration. This is equal to E integration over a closed surface ds. This is a sphere and its total area is 4 pi r square. Here we will take radius small r. This will be equal to the E into 4 pi r square. Or we can write E is equal to the phi divided upon, let's not write it the phi, leave it. Let this be the equation number 2. Phi is equal to q upon the epsilon naught and phi is equal to E 4 pi r square. Compare these two equations. Left hand side is the same. So from 1 and 2, we can say that E into 4 pi r square is equal to the q upon epsilon. E is equal to q upon 4 pi epsilon naught r square. Let's find the value of q in terms of the surface charge density sigma. We know that sigma is equal to Q upon A. A is the area of the sphere. This will be equal to Q divided by area of this sphere having the surface charge density sigma is 4 pi r square. R is the radius of the sphere. Therefore, Q is equal to sigma 4 pi r square. Now substitute the value of Q here. This will be equal to sigma into 4 pi r square divided upon 4 pi epsilon naught r square. 4 pi cancelled out. The electric field intensity at point P is equal to the sigma r square divided upon epsilon naught r square. This is the value of the electric field intensity at point P. Let's discuss two special cases. Number one, when R is equal to R. When R is equal to capital R. That means the value of the electric field intensity at this surface. Now E will be equal to sigma r square divided upon the epsilon naught r square. See the cancelled out. This will be equal to sigma upon epsilon naught. Now second point is, let's discuss the electric field inside this sphere. That means when R is less than capital R. This is very important. Since inside this sphere there is no charge content. The charge content inside this sphere is 0. That means Q is equal to 0. Therefore, surface charge density sigma will be equal to 0 and electric field intensity E will be equal to 0. E is equal to 0 because sigma is 0. That means when there is no charge inside a closed surface, electric field intensity will be 0. Next important point is E is equal to the Q upon 4 pi epsilon naught r square. This one. From this we can conclude that the electric field intensity of a spherical shell at a point outside the sphere is the same as a total charge Q is contained inside the sphere at radius at the center. That means a spherical shell is equivalent to a point charge at the center of this sphere. Hope you find this video useful and informative. Please like it, share with your friends, and don't forget to subscribe my channel. Thank you very much for watching this video.